Part 2 begins now. Couple questions. What's the period of the red one, which is this one? Well, from 0 to 2 pi. So that's my period. What's the amplitude? Well, this only goes up 1/2 of a unit above the x-axis, and it only goes down 1/2 a unit. So there it is. If I wanted to use the formula, I'd say, there's my A. Take the absolute value of 1/2. That's just the hard way. I like looking at the picture, but sometimes the formula helps. Now, what is the maximum for the red drawing? Well, it's how high it goes. That'd be 1/2. What's the minimum? That'd be -1/2. See how that's connected to the amplitude? All right, I'm going to show you one more thing. Be prepared. Now all of a sudden you're going to get hit with the letter B. You haven't talked about B very much. If B is negative, I think what you know at this point is it reflects over the y-axis. Now these sinusoids, sine and cosine, they've got a few new formulas that have nothing to do with y equals x squared, nothing to do with y equals the absolute value of x. It's only for these. So here they are. Amplitude, absolute value A. Yep, you're aware of that. Period. Here's a formula. Listen carefully. I've told you that 2 pi is the normal period for cosine, and it's the normal period for sine. Now, there's a huge clue. If B is 1, so look at B is 1, B is 1, and we put that in the formula here, we'd get 2 pi all over the absolute value of 1. Both of these are 1s. And what would that reduce to? That'd reduce to 2 pi. So, what happens if B is a 2 or B is a 1/2? Hold your hats. Now, let's take a look at this one. How do we get started here? We get started by drawing the parent function. 90, 180, 270, 360. Those are the biggies. Now there's a ton of stuff going on in here, a ton of stuff going on in here, here, and here. Now you got the gist. We start up here at the 1, and you go from 1 to 0, 0 to -1, -1 back to 0, 0 to 1. So there's my parent function, y equals cosine of x. Notice something? What's the period? Well, hopefully you have that memorized already. It's 2 pi. Now we're going to take this one. Maybe we'll use purple. We got a problem here, Houston. That's a 2. There's a 1 here. That tells me my amplitude is still going to be 1. So we're not going to mess with the amplitude on this one. I want to focus on the letter B. So if I take that 2 and I put it in that formula, 2 pi all over the absolute value of 2, isn't that just 2 pi all over 2, which is just pi? Watch this. This could be confusing at first. What I'm going to say to you is, the normal period, remember we said the normal period is 2 pi? This letter B is going to squeeze the period in half. So it goes from here to here. Now that's 360. I'm going to bring it all the way into here. Now watch this. I need to take this, recreate this drawing basically in half the time. So I start here. Notice in this amount of time, it goes down to -1 halfway and then back up to 1. So what's halfway here? Halfway is here. It's got to go down to -1 halfway. And then it's got to get back up to 1 by the time it ends, which is right here. It can go like this. Look what happened. It was horizontally compressed. There's some fancy language for you. Now what's the period? That's pi. Remember 180? What's 180? That's pi. So the formula does it, and then our drawing does it. Now, if that's the first time you've seen this, I give you permission to be confused. So I'm going to do this one. There's this function. What's the parent function? Parent function is still y equals cosine of x. So you better know what this looks like. Well, it starts at 1 to 0 to -1. Back to 0, back to 1. Get used to that. Just like a little bowl or vase or a tulip. Anyways, we got a problem. This is not a problem. That's telling me my amplitude is still going to be 1 when I'm done with this. So let's not worry about it. But b equals 1/2. If I take this formula and I go, okay, 2 pi all over the absolute value of 1/2, I know that's just going to be positive 1/2. What do you do when you divide by a fraction? Well, you better know something. What is 2/3 divided by 1/2? Well, that's the same thing as 2/3 over 1/2. Look at this one. Don't I just multiply by this guy's reciprocal? And if it's written like this, I take this, flip it, and multiply. It's the same thing. So now I have 2 pi divided by 1/2. That's the same thing as 2 pi. Take this bottom denominator fraction, flip it. What do I get? 4 pi. Now look at it. The normal period is 2 pi. That's my parent function. Now I need 4 pi. Well, that means if this is 360 and that's 2 pi, I got to go way over here. Am I still on the board? Well, I better bring that in a little bit. My drawing might be terrible. To 720. We doubled the normal period. So I got to go from 360 to 720. This is going to be challenging now. But then we got to take a snapshot of what does it do? Well, it starts at 1, goes down to -1, halfway. Well, if this is now 4 pi, I need to repeat that halfway. So here's my halfway point. So I know it starts here, and it comes like this, and it goes like this, and there we go. And then what does it have to do? Oh, I better pause that. I might have screwed that up. All right, my brain was fried right there. I was doing it right. Halfway is where the low point is. Halfway to 720 is 360. So now I have to repeat this picture from here to here. So that's going to look like that. Now I know I chopped off a big chunk, but that red one is this right here. That was horizontally stretched by a factor of 2, which is really weird. See, that's a half. It stretched it by 2. This was a 2. Remember what that did? It compressed it by 2. So you could block away a rule. Fraction stretches it horizontally. Whole number, strangely, compresses it. Because think about it, you're going to divide by whatever b is. So if this is a fraction, you're going to flip it and multiply, making it bigger. If it's a whole number, like a 2, you're actually going to divide, making it smaller. So I hope mathematically it's kind of making sense. So a few things they could ask us now about that red one, which is this one. What is the amplitude? Well, the amplitude did not change. You just look at it. Down 1, up 1. Period. Now that is 4 pi. What's the max? Max is still 1. The min is still -1. All right, there you go. Now, again, huge pre-lesson. Please take the time to watch. Example problem.